Hey guys, welcome back. And what we're going to do today is we're going to take a Rolex President 1803, it's from the 70s, and we're going to melt it down for the gold content. Almost all of it. The movement is still good, and I actually have a buyer for it. So since I've been recording this, it's actually already sold. The band was in pretty rough shape. It had a lot of stretch, which was very important in watches like this. The links, some of them were damaged, so it really didn't justify trying to fix it. Just sold it with a replacement bracelet, and this is the old one. So this is solid 18 karat gold, including the clasp, and I promise you it's real. It says 750 on it, which means it's 18 karat gold, made in Switzerland. It has what's called a bark bracelet in the middle, and there's the it was well worn. It may look clean in the videos here, but you can see in the middle there's some damage to it. It's pulled very hard, like it maybe caught on something. I'm not really sure. Anyway, so what we're going to do, in order to properly dissolve this gold, we have to enquart it with silver. And so there's a formula, depending on whether it's 9, 10, 12, 14, 18 karat, and so on, gold. You have to reduce the content, the gold content, down to about 25%. So what we're going to do, we're going to weigh it, and we're going to multiply the weight times 1.265 to get the amount of silver that we're going to add. So in this instance, it weighs 60 grams. So we're going to go ahead and grab a beaker, add the silver to it. Go ahead and tare it. The silver that we're going to add is in powdered form, and it's recovered from previous gold refinings, and it's like from sterling silverware that I've refined, and so on and so forth. The magic number we are looking for is 120 grams. There we go. So we will take the bracelet, add it to it, and if you have a torch, you can melt it down and blend it into an alloy in your melt dish. Or in my case, I took the easy way out and I bought a cheap little Chinese oven, furnace I guess, put it in there, fire it up, get it up to about 1100 degrees centigrade. Make sure it's stirred very well. I have a graphite rod that I'm going to use to stir it, and then we will dump it into cold water to create as much surface area as possible. So here we go. You can see it's about 1100 degrees. Quite hot. Nice liquid there. Gonna take my graphite rod, stir it up very well. Make sure there's no gold stuck on the end of that. So I had to set it up on a tripod here to do this. In hindsight, I really should have more water to cool this off, but dump it in there. You can see how it burned the paint very quickly there. And so we'll take that out and proceed from there. So now we're going to get on to the refining process. What you're seeing in this 4-liter beaker is gold that has already been enquartered with silver from some other scrap jewelry I'd picked up at yard sales and so on. If you came here wanting to know exactly how much is in that bracelet, the answer is 1.45 ounces of gold. And so that's what I'm actually putting in there right now. That's from what we have enquartered. You can see it's a very nice, bright, shiny finish, but what we want here is maximum surface area for the acid to dissolve everything, all the base metals, including the silver, except the gold. Start off adding distilled water. I'm going to use about 1,000 milliliters. Now let's go 1,500 milliliters. And add to that 70% nitric acid. 68 to 71, 72% will suffice here. When you first start out with this amount of gold, you're probably going to need 100 to 200 milliliters. So I just go ahead and start it pretty strong. The reason I have a 4-liter beaker, 4,000 milliliter beaker, is because as we add nitric acid, as everything heats up and starts to react, the reaction gets very violent and it'll bubble up and fizz, and it can potentially overflow. You can have a runaway reaction if you're not careful. So we're going to go ahead and put this on max heat on my cheap little stove and let it dissolve. The brown gas that you're going to see is nitrogen dioxide, and that is a very, very dangerous gas, harmful to your health. Make sure you're either doing this in a fume hood or you're doing this outside in a well ventilated area as I am right now. So you can see the gas start to develop, and it's going to get much stronger. So unfortunately, I lost a lot of video here that I thought was recording, and it wasn't. I'm fighting the heat here in the East Texas summertime. My camera kept overheating and it would shut off, so I lost a lot of the footage here. I'm gonna explain quickly what it was happening. All the base metals were dissolved, leaving the gold. You're going to filter out all of the solution that you had, keeping that solution because it has silver in it. We'll recover that later. Take the gold, put it back into a beaker, and we're going to create aqua regia. That's nitric acid and hydrochloric acid. It will put all the gold in solution. It will turn a kind of a orangish color, and then what you're going to do is precipitate that using a product called Stump Out, which is sodium metabisulfite, which you can get it at Home Depot for about $5 or $6. So you repeat this process 2 or 3 times to purify the gold. Bring it up to 3 or 4 nines fineness, which is 99.9 or 99.99%. The clearer the liquid, the higher the gold purity. So what you're seeing here is me just keeping an eye on it. Right before you precipitate the gold, you're going to add a lot, turn the heat off, you're going to add a lot of distilled water. It helps make the process go smoother. So you can see the clarity here, very high quality, high purity gold that we're going to have. Any impurities are left as solids in the bottom. There you go. So we're going to filter it out and then precipitate, or we did I'm trying to keep all these videos straight. So we filtered it and put it back into a new clean beaker. So now we're going to precipitate it. What you're looking for, it's going to turn black. And when you start seeing that white foam at the top, that usually tells you that it's all been precipitated. But there's another way to test. You're going to use a stannous chloride solution and some filter paper, and you can either make your own or you can buy it online on eBay, wherever else. So there you see when all the gold color goes away, you know that it's all been precipitated. So that foam, there we go, we're starting to turn black. That, because it's not doing it immediately, that tells me that I probably had a little bit too much nitric acid remaining. So the sodium metabisulfite is neutralizing the acid before it precipitates the gold. So we have our stannous chloride solution. going to dip it in on some filter paper, and if it turns black, that tells us we have gold in solution. If it's red, it's slight gold. So we have no reaction, which tells us that all of the gold in this solution has precipitated. So now we're going to let it sit and settle, usually for 30 minutes to an hour, and all of the gold will sit at the bottom of the solution. There we go. So that is pure gold at the bottom there. There we go. So we're going to filter that solution. Catch any gold, and we'll save the filter papers for later. So again, you repeat this process again. Put the gold back into solution. So you put nitric acid, just a few milliliters per gram of gold is what you're going to need. You can still see a couple little bubbles there, but this is what we ended up with. This is a total of 5 ounces of gold, and it's on my Sigma to show you that it is 3 nines or greater fine, right in the middle. So I wanted to thank you guys for watching, and if you could like, comment, subscribe, really appreciate it. Like growing this channel, and if you want to see more videos like this, just let me know in the comments below. Thanks again for watching. We will see you next time.